very quickly, I need to show you a quick summary. Okay, so for example, let's say if we have a log y equals to log base a of x. Okay, we need to be concerned with two versions. Okay, so the first version is this. So you need to know the basic logarithm graph. Okay, so the basic logarithm graph, how is the shape like? Going up like this is going up exponentially, correct? So logarithm is the other way around. How? Correct. So from here like this. Okay, so this is exponential. Okay, so you need to think of it as that exponential is reverse of logarithm. Okay, so the exponential graph is reverse of logarithm. So logarithm would be like this. Okay, so if the exponential cut at 1 or the constant k, cut at the constant k, over here it also cuts at 1. Okay, so this is the basic thing first. So the logarithm graph, okay, means like this. Okay, now this graph is when a is more than 1, when the base is more than 1. Okay, now what happens is because the base, right, can be half, can be 0.2, can be 0.1, cannot be 0, cannot be 1, but it can be smaller than 1, correct? So what if our base is between 0 and 1? What will the graph look like? It will look like a flipped version of this thing. So it will look like this, x and y and this. So it will look something like this. Okay, the other way around. So it is something like your exponential graph, this one is like this, right? So the other one is like that. Yeah, then you flip, become like this, that kind of thing. Okay? Can, so it's just flip along the axis. Negative log ax also flip vertically. Okay, so you just pay attention. If it's a negative graph in front, you flip. If it's the base, check the base. If the base is small, then it will be like this. So when we draw graph, right, the most important feature is the intercepts, correct? So the first one over here, the intercept is correct. Okay. This one, when x is 0.5, log 0.5, 0.5 is 1. Okay, very nice. Okay, so this one pass. Okay, this one pass. So the basic shape of logarithm is like this, but because the base is less than 1, so you need to do a little bit of flip. Okay, so if you don't want to remember so much, you just need to remember of y equals to e power x or any exponential graph. If the x has a e to the power of x, okay, or actually 2 to the power x, if this base is less than 1, correct? If this base is less than 1, then your graph is not an exponential graph, it will decrease exponentially, correct? And then you need to do the flip this side, and then it will look something like this. Okay? Otherwise, you just try to remember. Okay? So how to remember? Where? Left hand, right hand. Remember? Positive, negative. Right? So the negative one will be something like this. Now, this one. Okay, this is the basic logarithm graph. Correct? So the basic logarithm graph looks something like this. Correct? Looks something like this. But I wrote here horizontal flip. Correct? So means where is the graph supposed to be? Horizontal flip. Flip horizontally means flip in this dimension. So your graph is actually, this is a good graph by the way. Okay, but the graph is actually the other direction at 1. Okay, this graph is at the other direction. This is the basic graph. Then you need to do a horizontal flip to this graph. Okay? From book. Okay. Next one. This one, okay, fine. This one is good. Okay, but one thing to be very anal is this one over here. Cannot touch the x-axis. Cannot touch the axis. Okay, so it must be something like this. Okay? Cannot curve out, just approaching the axis. So this one must be very careful. Cannot touch the axis, cannot curve outwards, but towards the axis. Okay? Can Okay, so this one, done. So more or less we covered most of the variation of the graphs. Okay? Okay, so let's take a look at question 2, part 2. Part 2, we need to determine the equation of a straight line to be drawn on this graph such that we will solve this. Okay, so we need to draw a straight line on the graph, or we need to find the equation of a straight line to draw such that we will be able to solve this. So remember, right, whenever we do solving this one with graph, we need to have two equations, remember? And this skill is actually from your AMath. AMath, when you draw this curve, and then you need to draw another line and find the points of intersection. So in the same way, we need to get the ln x from this equation. Okay, we need to get the ln x from this equation over here. So how do we get the ln x from this equation? This is base e. So I will throw the base e to the other side. So this will be ln x is equals to 2 minus 3 over 2x. So this is actually this graph. So the graph that I need to draw is actually, I need to draw this one. 2 minus 3 over 2x. So this is actually the graph that I want already. So I just need to draw this one to match. Okay, so after drawing this line, then you have two intersections and then you get your solution. Okay, so this is the final answer. Okay, so this one is actually a skill from AMath. Okay, quite straightforward, but you need to know the basic idea. Okay, in order to look one more time, so the basic idea is, based on the points of intersection from two graphs, you get your solution. But where do you get the equation first? You need to come here and refer to the original thing that you've drawn. Then you just try to obtain this from the equation given. Okay? Anyone need question 3? Question 3? I think I do question 3 ba. Question 3 need to do. Okay. Huh? What? Why what? No x? Why ln x? Because the one that we draw was ln x. So we need to get the ln x first. Okay. Let's look at number 3, part 1. Now on the same axis, we need to draw two graphs. We need to draw a log base 15x. So log base 15x, right? Which shape is it? Number 1, number 2, number 3. Which shape is it? Log base 15x. So is it this shape, or this shape? 1, 2, or 3? Number 2, because the base 15 is a positive number, so it will be following the basic logarithm curve. So I have something like this. So basic curve, my advice start from the bottom so that you don't intersect or you don't, so this is 1 over here. Okay? So this is y equals to log base 15 of x. Okay, the second one, log base 0.8 of x. So 0.8, which graph is this? Number 1, number 2, or number 3? Log base 0.8. This is negative x, right? Negative x, so log base 0.8. Type 1, because the base is smaller than 1, so your graph is actually a negative graph. Okay, so it will look something like this also, like that. Okay, I try. So y equals to log base 0.8 of x. Okay? So take note, this is line number 1. Okay, I draw with different colors so that we can see. Okay? Okay, so part 2. Using the graph, using this pair of graphs, find the range of values of R. Yeah. First page, you go back to first page. Page 1. You go back to page 1. Are you at page 1? Okay, you look at the base. Then you look at this base. Okay, can Okay, so let's do this. Okay, so using the graph to find the range of values. So making use of the graph, we are not solving for y, but we are solving for x, range of values of x. So it means we need to look at the horizontal range. Okay, so find the range of value of x for which log base 15x is more than 0. So when is the graph more than 0? The graph is more than 0 at this portion, correct? Agree? The graph is more than 0 at this portion, so the x will need to follow this portion. So it means that if you are looking at this region, my x I will need to start to look at this region and forward. Okay, so the answer for the first one is it A and B? So my answer for the first one is x is more than 1. So when x is more than 1, I get the graph which is more than 0. Okay? Okay, second one. Log 0.8x less than or equal to 0. So where is it less than or equal to 0? When the graph is negative, it's less than 0, correct? So it means that I also need to look at the same region. When x is more than 1, then the graph, the blue color graph, is below the axis. So it's the negative part. But over here, because it's equal, right? So I need to take this line, this point also. Okay? So for part B, x is more than or equal to 1. Okay? Okay, the last part. For C, now which region, okay, so let me remove this number line thingy. Okay, which region where you get log base 15x higher than log base 8 of x? Which region? Which region of x where you get log base 15 of x higher than log base 8 of x? So let's take a look at this part. Which one is greater? The blue color is greater, correct? For the part before 1. Right? And for the part after 1, the black color part is greater. Correct? So means which are the range of x? The x that we are referring to is this region over here. Also this region. So for part C, the answer is also x more than 1. When log base 15x is more than log base 0.8 of x. Okay? Now, then what about before that? Let's say if the question twists a bit, when is log base 15 of x less than log base 0.8 of x? If I flip the inequality, so what is my answer? When x is smaller than 1 only? Bigger than 0. So x is in between 0 and 1. So if it's the other way around, so we are only looking at this region between 0 and 1. Okay? Can So the graphical method is like this. So if you get the graph, you look at the where is it positive, negative, then you read the corresponding x. So it's like your quadratic graph. Okay?